Hello, welcome all. So, continuing the Ruta Academy, today I would be discussing in brief how to approach or how to plan a root ablation by seeing the intravascular imaging. First of all, we have to be very, I think, good in interpreting the images of intravascular imaging because many times that gives a clue how to approach a particular lesion. So there are a few challenges once we are treating a calcified lesion. One is poor response to the angioplasty. These calcified lesions are difficult to dilate, and even if you are dilating, they are prone to dissection, and they may preclude a stent delivery to the desired location and can prevent an adequate stent expansion, and that can lead to stent thrombosis. So once we are dealing with these lesions, so many times we may not expect that calcium can be problematic. So road can be rocky as compared to the greeny road. So what are the things you should see on imaging? So I would be discussing this slide. This is important slide and a basic slide. So this is a IVUS image which shows a central catheter with asterixis mark, which shows a wire artifact. And after that, there are three layers. Innermost is intima, then media, then adventitia. So in the first uppermost image, it is a normal three layers, and in downward images, in lowermost image, in the mid image, you can see there is a mixed plaque with fibrofatty plaque, and in the third lowermost image, which is on the right side, you can see a concentric ring of white calcium. So in ultrasound, in USG, in IVUS, you can see this looks like a white. So it's the calcium which can have a post-acoustic shadowing as well. So in the last image on the right side, we can see we are dealing with a calcified lesion. So, but when we compare it with OCT, we can see that the same on figure B, you can see there is white lucency which has a post-acoustic shadowing that is black. That means this is the thick calcium. And on the left side in figure A, you can see it is the OCT image in which this well demarcated low backscatter area is seen, which has a particular proper margins. So as compared to the fibrous, it has a lesser intensity. So it is a bit dark as compared to the bright fibrous structure. So there is attenuation of the signals, but there is a definite demarcation of the boundaries. So this is how, and it is almost same in the C and D picture. So on IVUS, we should see it is a bright hyperechoic deposit with corresponding sharp edged acoustic shadowing. So it has a high sensitivity of 90% and high specificity for large dense calcific spots or microcalcification clusters. And we can also divide this target calcium but in the form of arc. It can be 80 degree, it can be superficial, it can be deep. So in superficial, we usually say it is near the catheter and in the 50% of the intima and the media of the plaque, and in deep, it is away from the catheter and it goes in the lower half of the plaque. So this is arc examples. We can see it is mild arc less than 90 degree, then it is moderate 90 to 180 degree, and last one more than 180 degree. And one thing about the calcium nodule, many times it may not be visible on angiography or cine angiography, but we can see this is a catheter. On left side image, we can see center is a catheter, then there is a bright dense structure which is near the catheter, and behind this there is the post-acoustic shadowing. The rest all the places there is no calcium. And this is the OCT image on the right side of the different patient. We can see a well demarcated conical type of structure seen in the 2 o'clock. So this is again a calcific nodule. So these are the things that should be in our mind. So there are various other scoring system also that I will discuss in the detail later on. And so this is how we should try to approach a calcific lesion. So we'll be discussing the imaging in detail in the next session. And thank you for patience.